The first available method is by using empirical equations, which includes Dalton's law, factors which includes wind velocity, temperature, atmospheric pressure, etc. Under empirical equations are A. Fitzgerald's equation with the formula of E is equals to quantity of 0.4 plus 0.124 V times the quantity of E sub S minus E sub A, whereas E stands for evaporation in millimeters per day. E sub S stands for saturated vapor pressure at the temperature of water surface in millimeter of mercury. E sub A stands for actual vapor pressure of air in millimeter of mercury. V stands for mean wind speed at the surface in kilometers per hour. B is the Horton's equation with the formula of E is equals to 0.4 times the quantity of phi times E sub S minus E sub A, where the phi is equivalent to 2 minus E raised to negative 0.124 times V, whereas phi is the function of wind velocity. E stands for evaporation in millimeter per day. E sub S is equals to saturated vapor pressure at the temperature of water surface in millimeter of mercury. E sub A is the actual vapor pressure of air in millimeter of mercury. V stands for mean wind speed at the surface in kilometer per hour. Next equation, C, Mayer's equation. Mayer's equation with the formula of E is equals to C times the quantity of E sub S minus E sub A times the quantity of 1 plus 0.06215 times V, whereas E is equals to evaporation in millimeter per month. E sub S stands for saturation vapor pressure in millimeter of mercury corresponding to the mean monthly temperature of air. E sub A stands for actual vapor pressure in air based on mean monthly temperature and relative humidity. V stands for monthly mean wind velocity in kilometer per hour at 10 meter above the ground level. C stands for C is equivalent to 15 for small shallow ponds, while C is equivalent to 11 for large or deep bodies of water. Next equation is D, the Rower's equation. Rower's equation with the formula of E is equals to 0.771 times the quantity of 1.465 minus 0.000732 P sub A times the quantity of 0.44 plus 0.07334 times V times the quantity of E sub S minus E sub A, whereas E is equivalent to evaporation in millimeter per day. P sub A stands for mean barometric reading in millimeter of mercury. E sub S is equals to saturated vapor pressure on water surface. E sub A is the actual vapor pressure in air. V stands for mean wind speed at the surface in kilometer per hour. Last equation, which is the Lake Mead's equation. Lake Mead's equation with the formula of E is equals to 0.0331 times V times the quantity of E sub S minus E sub A times the quantity of 1 minus 0.03 times the quantity of T sub A minus T sub W, whereas T sub A stands for average air temperature in degrees Celsius. T sub W stands for average water surface temperature in degrees Celsius. E stands for evaporation in millimeter per day. P sub A stands for mean barometric reading in millimeter of mercury. E sub S stands for saturated vapor pressure on water surface. E sub A stands for actual vapor pressure in air. V stands for mean wind speed at the surface in kilometer per hour. Estimation of evaporation problem using empirical equation formula. The following meteorological data pertain to a large reservoir with a water spread area of 15 km. The data represents average values for the day. Water temperature, T sub W, is equals to 24 degrees Celsius. Air temperature, or T sub A, is equals to 26 degrees Celsius. Atmospheric pressure, E sub A, is equals to 752 millimeter of mercury. Wind speed at 0.5 meter above ground level, or V, is equals to 25.3 km per hour. Relative humidity is equals to 46%. Estimate the average daily evaporation from the reservoir and also the evaporation losses from the reservoir for a period of 1 week using different empirical formulae. Here's the saturated vapor pressure corresponding to the water temperature of 24 degrees Celsius referred from the given table below. 24 degrees Celsius is equivalent to E sub S equals to 29.831. The corresponding value of E sub S in MB for temperature of 24 degrees Celsius referred to the table is 29.831 MB. Convert it using this formula. 1 millimeter of mercury is equals to 1.33 MB. For 24 degrees Celsius, 29.831 MB over 1.33 MB is equals to 22.43 mm of mercury. Saturated vapor pressure corresponding to the air temperature of 26 degrees Celsius referred to the table is 33.608 MB. For 26 degrees Celsius, 33.608 MB over 1.33 MB is equals to 25.27 mm of mercury. Relative humidity is equals to actual vapor pressure in air, E sub A, over saturation vapor pressure at air temperature. Relative humidity is equivalent to 0.46 equals to E sub A over 25.27 mm of mercury. Compute. E sub A is equals to 0.46 times 25.277 mm of mercury, which is equals to 11.62 mm of mercury. A. By using Fitzgerald equation, with the formula of E is equals to quantity of 0.4 plus 0.124 times V times quantity of E sub S minus E sub A. E is equals to quantity of 0.4 plus 0.124 times 25.3 times the quantity of 22.43 minus 11.62. E is equals to 3.537 times 10.81. E is equals to 38.24 mm per day. Evaporation loss for 1 week is equals to 7 days times 38.24 mm per day times quantity of 15 kilometers times 10 raised to 6 over 1000. Evaporation loss for 1 week is equals to 4.0152 times 10 raised to 6 cubic meter, or 4 million cubic meter. By using Horton's equation, with the formula of E is equals to 0.4 times phi, quantity of phi times E sub S minus E sub A, where phi is equals to 2 minus E raised to negative 0.124 V. Given V is equals to 25.3 kilometers per hour, phi is equals to 2 minus E raised to negative 0.124 times V, which is 25.3. Phi is equals to 2 minus 0.0434. Phi is equals to 1.9566. E is equals to 0.4 times the quantity of 1.9566 times quantity 22.43 minus 11.62, where E is equals to 12.91 millimeters per day. Evaporation loss for 1 week is equals to 7 days times 12.91 mm per day over 1000 times 15 times 10 cube raised to 2. Evaporation loss for 1 week is equals to 1.356 times 10 raised to 6 cubic meter, which is equivalent to 1.356 million cubic meter. C by using Mayer's equation with the formula of E is equals to C times the quantity of E sub S minus E sub A times the quantity of 1 plus 0.06215 times V. For large or deep bodies of water use, C is equals to 11 for a month. For a small or shallow ponds, C is equals to 15. V sub 10 over V sub 0.5 is equals to 10 over 0.5 raised to 0.15. Wind speed at 0.5 above ground level is equals to 25.3 kilometers per hour. V sub 10 is equals V sub 10 over 25.3 is equals to quantity of 10 over 0.5 raised to 0.15. V sub 10 is equals to 25.3 times 20 raised to 0.15, which is equals to 39.653 km per hour. E is equals to 11 over 30 times the quantity of 22.43 minus 11.62 times the quantity of 1 plus 0.06215 times 39.653, where E is equals to 13.73 millimeter per day. Evaporation loss for 1 week is equals to 7 times 13.73 mm per day over 1000 times 15 times 10 raised to 3 raised to 2. Evaporation loss for 1 week is equals to 1.442 times 10 raised to 6 cubic meter, or equivalent to 1.442 million cubic meter. D, by using Rower's equation with the formula of E is equals to 0.771 times the quantity of 1.465 minus 0.000732 P sub A times the quantity of 0.44 plus 0.07334 raised to V times V times the quantity of E sub S minus E sub A. P sub A is equals to atmospheric pressure, which is equivalent to 752 mm of mercury. E is equals to 0.771 times the quantity of 1.465 minus 0.000732 times P sub A, which is equivalent to 752, times the quantity of 0.44 plus 0.7334 times 25.3 times the quantity of 22.43 minus 11.62. E is equals to 17.5 millimeter per day. Evaporation loss for 1 week is equals to 7 days times 17.5 millimeter per day over 1000 times 15 times 10 raised to 3 raised to 2. Evaporation loss for 1 week is equals to 1.84 times 10 raised to 6 cubic meter, which is equivalent to 1.84 million cubic meter. Last equation is by using Lake Mead's equation with the formula of E is equals to 0.0331 times V times the quantity of E sub S minus E sub A times the quantity of 1 minus 0.03 times the quantity of T sub A minus T sub W. Given is V is equals to 25.3 km per hour. E sub S is equals to 22.43 mm of mercury. E sub A is equals to 11.26 mm of mercury. T sub A minus T sub W is equals to unknown. Air temperature T sub A is equals to 26 degrees Celsius. Water temperature T sub W is equals to 24 degrees Celsius. Change in temperature T sub A minus T sub W is equals to 26 degrees Celsius minus 24 degrees Celsius is equals to 2 degrees Celsius. E is equals to 0.0331 times 25.3 km per hour times the quantity of 22.43 of mercury minus 11.26 millimeter of mercury times the quantity of 1 minus 0.03 times substitute the value of change in temperature 2 degrees Celsius. E is equals to 8.51 millimeter per day. Evaporation loss for 1 week is equals to 7 days times 8.51 millimeter per day over 1,000 times 15 times 10 raised to 3 raised to 2. Evaporation loss for 1 week is equals to 0.894 times 10 raised to 6 cubic meter, which is equivalent to 0.894 million cubic meter. Energy balance method is the second available method in our report, with the formula of ER is equals to R sub N over P sub W times L sub V is equals to R sub N over L, which L is equivalent to P sub W times L sub V. Whereas E sub R is equals to energy, R sub N is equals to net radiation, L sub V is equals to latent heat is equals or equal to 2.501 times 10 minus 2370 T in degrees Celsius. P sub W is equals to density of water. Energy balance method involves application of the law of conservation of energy. Energy available for evaporation is determined by considering the incoming energy, outgoing energy, and the energy stored in the water body over a known time interval. Estimation of evaporation from a lake by this method has been found to give satisfactory results with errors of the order of 5% when applied to periods less than a week. H sub N is equals to H sub A plus H sub E plus H sub G plus H sub S plus H sub I. H sub N stands for net heat energy received by the water surface, which is equivalent to H sub C times the quantity of 1 minus R minus HB, H sub B. H sub B is equals to back or long wave radiation from the water body. H sub A is equals to sensible heat transfer from the water surface to the air. H sub G is equals to heat flux into the ground. H sub S stands for heat stored in the water body. H sub E is equals to heat energy used up in evaporation, which is equals to density times L times E sub L, where E sub L is equals to evaporation, L is equivalent to latent heat of evaporation, and P is equals to mass density of the fluid. H sub I is equals to net heat conducted out of the system by water flow at vected energy. Energy balance in water body This is the energy balance in a period of 1 day. All energy terms are in calories square millimeter per day. If time periods are short, H sub s and H sub I can be neglected as they are negligibly small. All terms except H sub A can either be measured or evaluated indirectly. H sub A is estimated using Bowen's ratio. Here is a figure shown about the back radiation. H sub B is reflected from the heat stored from the water. Heat lost to air, H sub A.